Hello, and welcome to the third video in the Lemonade SDK series. In the first video, we covered the Ryzen AI software stack, focusing on the components needed to run LLMs on Ryzen AI PCs. The second video reviewed the installation steps and commands to run LLMs on your PC. In this video, we'll demonstrate more advanced uses of the Lemonade SDK, including benchmarking and accuracy tests, as well as the Python APIs available through the SDK. Let's get started. If we navigate to the featured LLMs table on the overview page, we provide a list of supported LLMs, along with links to CPU and hybrid examples. Each link in the table provides an end-to-end guide with comprehensive instructions for testing, benchmarking, and evaluating the accuracy of a model on a given hardware. Let's click into the Llama 3, 1 billion parameters example. This guide focuses on hybrid execution mode with Llama 3, 1 billion parameters model. We've already completed the prerequisites and the setup instructions, including activating our Conda environment. In addition to the setup instructions, this guide includes validation instructions and Python application integration. Here's the specific example for prompting this model with the hybrid execution flow. This is the same as what we showed in the previous video. What I want to show next is the responsiveness section. Let's do something a bit more interesting. A performance benchmark. We can copy and paste the next command. Let's quickly walk through what it does. First, Lemonade is the tool. We provide the input model checkpoint. We'll load it up as before, and this time we'll call the OGA bench tool to perform a benchmark. This setup includes 5 warm-up iterations to prepare the cache, followed by 10 iterations to measure the time to first token and tokens per second. The prompt length is set to 1024, and we're specifying 64 output tokens. When this completes, the results are printed to the console. This includes the time to first token in seconds, the number of tokens per second, and the maximum memory used. What are ways that you can prompt a model using Lemonade? The benchmarking tools offer 3 different ways of providing a prompt. 1. Give it a number, and the tool will create a synthetic prompt that has exactly that many tokens. The second option is to provide it with a string such as, "Tell me a story." And the third option is to give it a path to a text file, and whatever text is in the file will be loaded as the prompt. That's really useful if you're doing repeatable benchmarks of long passages of text. The next thing on here would be task performance. Here's an example of a command for running the MMLU test. The Massive Multitask Language Understanding benchmark is a comprehensive evaluation framework designed to assess the capabilities of language models across a wide range of subjects and disciplines. It encompasses a diverse set of questions covering topics from humanities to natural sciences, aiming to measure a model's depth and breadth of knowledge, and its ability to generalize across different types of language understanding tasks. Here, I ran the management test. It asks the LLM roughly 100 questions and then grades its performance. I've sped up the video of this test since it can take some time. To see the complete list of test subjects, see the MMLU accuracy README, where a table of the subjects and the corresponding command is provided. Another feature we can demonstrate is the high-level Python API. This API is modeled after Hugging Face transformers, making it familiar to users of that library. It includes a from pre-trained API, which you can call with the same checkpoint used in the previous command, specifying that you want to run an OGA hybrid model. This will return a model and tokenizer that functions similarly to Hugging Face's model and tokenizer. You run the tokenizer to get input IDs, pass those input IDs into the model's generate function to get a response, and then decode the response with the tokenizer to print it out in human-readable language. Now that we've introduced the Lemonade API, let's try running it in a Python script. To do this, I'll launch VS Code. Paste in the code provided here. Save the file. And then we can run the script. Make sure to activate your Conda environment before executing the code. In the script, we prompted the LLM with "This is my prompt," and the response from the LLM was to finish the sentence and state that it's going to start writing a story, but since the max output tokens was limited to 30, it got cut off. Next, let's talk about streaming. You may have noticed before that the entire output just popped out on the terminal all in one shot. What streaming does is it displays each token as it becomes available. We'll copy the example code provided into a new file, save it, and then run the script. There you go. It was pretty fast, so I hope you caught it. Streaming allows the individual tokens to be used as they become available. In this video, we discussed how you run performance benchmarks to get the time to first token and tokens per second. We also showed how you can run tests like MMLU to evaluate the accuracy of your LLM. And lastly, we showed how to run blocking and streaming examples using the Lemonade Python API. In the next video, we'll show you how easy it is to upgrade your application to integrate Ryzen AI LLMs using the Lemonade SDK.